Now we have done transaction properties, asset properties, okay guys, states of transactions. Now come to the main point, concurrent execution. Okay guys, so what is it, and start from scratch. So multiple transactions are allowed to run concurrently in the system. So we have seen in the previous tutorial, we have a transition in which read write operation are there. Okay, and read means read from the database, write means write in the memory, okay, database. So what happens, so in concurrency what happened, our in our system there are many transactions are running parallelly. Okay, so their advantages, increase processor and disk utilization leading to better transaction throughput. Okay, throughput means number of transaction, okay, per second. For example, one transaction can be using the CPU while another is reading from our writing to the disk. Okay, reading from or writing to a disk. So this will increase the processor and disk utilization simultaneously. Reduced average response time, that's we have studied in operating system also. For transaction, short transaction need not wait behind long ones. Okay, means we have many transaction, and some transaction are quite seconds and some are taking high time. So the short transaction will be executed running in the less response time. So it's saying reduced average less average time. Okay, now concurrency control schemes. Now mechanism to achieve isolation. Okay, now what we want that in our system we have to execute multiple transaction parallelly. Okay, so that we get these advantages. But we want also one thing, that all these things will be done in isolation, means all transaction will think that it is alone in the system. Okay, that is to control the interaction among the concurrent transactions in order to prevent them from the destroying the consistency of that database. So what happens guys, our database has many things, okay, and many things are same. So we have to manage these things so that our transaction will not go into the, our system will not go into the inconsistent states. Now that's another main thing, schedules. Okay, a sequence of instruction that specify the chronological order in which the instruction of the concurrent transaction are executed. Okay guys, so what happens, a schedule for a set of transaction must consist of all instruction of those transactions. So guys, you can see this is transaction 1, this is transaction 2, and this is whole is schedule. First it run commit, then at the time T2 will not involve, at the time of completion of T1 T2 will start their journey and commit. That's a schedule. Now it's a set of transaction. Okay, must preserve the order in which the instruction appear in each individual transaction. Suppose read is here and write is here, so order is maintained. Okay, we can't do that write is first at after read and read is before write. That's not possible. And that same chronological order. Okay, that's a must point. A transition that successfully completes its execution will have a commit instruction at the last. You can see this is the journey point from read A to write B, and at last it is committing. And committing, what will it will reflect in the database, and same for it, read A to write B, all the instructions are executing, at the last it is commit. Okay guys, a transition that fails to successfully complete its execution will have an abort instruction as an last statement. we have discussed in the previous what is abort. Okay, now let us look an example of schedule 1. T1 transfer, again old example. T1 transfer $50 from A to, and T2 transfer 10% of the balance from A to B. Okay guys, so what happened? We have discussed this transaction, how to send $50 from A to B. Now T2 has another concept called 10% from A to B. Now what happened? First of all, see the logic. First, in our T1, first of all, we have to send $50 from A. So first read from database A, then update the value of A, write A in the database, again read B from database second person and update the B, and then write B and commit. That's it, we have seen. Now new thing is 10% of the balance from A to B. Now read A, make a temporary variable and assign the 10%. A into 0.1, it's a 10%, 10 upon 100. Okay, and then A equals to A minus 10. We have updated that value, write A. Okay, then read B, and again the temp value will add it into the, so A 10% is transferred to B and then commit. That's it. So these two transitions will run simultaneously. What happened? Um, in that manner, first it run T1, and after committing T1 then T2 will run fully. So that's called serial schedule, in which T1 is followed by T2. Okay guys, so that's about the our serial schedule. Okay, so let's look that table. Suppose A has 100, B has 200. A has 100, B has 200. Okay, now A plus B, A plus B. Okay guys, so in initially A has 100, B has 100, A plus B is 300. Start when write A, that point. Okay guys, so at that time what happened? Our we have minus 50 from A, so A is updated value 50. So in spite 100 it has 50 value because updated A, and B has originally 200. We are here, so B's value is not affected, 200, then 50 to 50. Okay, so now value is inconsistent. If system failures, our system will be inconsistent. But now system is running. Now what happens? First stage 300, at the second stage when write A it has 250, and the third stage when B receive and write B, at that stage what happens? A is updated to 50 and B is updated to what? Plus 50. Okay, so 50 plus 250, 300. So originally and at end of the transaction are same. So that means our transaction is preserved and there is no problem. Our system is consistent. Okay, now T1 is committed, that means this value will reflect it into the database. Now again read A, temp A and write A. Okay, T2 ne write A. So what happens? It reduced the some value. What? How much value? It has 50. It has originally 50 and it read 50. 10% means minus 5 from it. Now it 45 and we write A. So 45, and at that stage B is not affected. So B is originally 250, now 250, but A is 10% less, 45, and we add it to, so it is 295. It is inconsistent at the time. Okay guys, now we are here. Okay guys, write B. So at that time A is minus temp and B is plus temp, and we have write B. So what happens? 45 as it is, and B have 5% more, 10% more, 255, and when we sum it to 300, so you can see this stage and this stage are same. Okay guys, so our system is preserved and consistent at all time. Okay, yellow represent inconsistent, मतलब transaction is running, and green means green represent transaction is consistent, committed, and red means inconsistent. In the another schedule we will see the how it possible.